Hello, everyone. Today, I'd like to talk about how to make computer vision a lot more easier. So this is going to be a little bit more introductory of how to get started in computer vision with a little bit more easier way. My name is Onuralp. I work on Supervision GitHub repository over years. And I did develop a couple of stuff in there as well, and mostly contributing the repository itself as well. So first off, what is Supervision? Supervision is basically gives you the reusable computer tools that you can basically load your dataset or load your model to plug into the system and use it for any purposes cases based on what you need, such as classification, detection, or segmentation. For convenience, we create also connectors that you can easily use on popular libraries for ultralytics, transformers, or etc. Of course, we are supporting many more libraries. On this case, you can also make your own custom connector because the library we created in Python is basically extendable. You can create your own custom solution, and you can making sure that it gives you the same output what you need when you do detections. So first off, let's start about detections. Detections is basically transform the various object of coming from the detections model and basically making a single unified format. And it also gives us the ability to change the data based on what you need. You can filter it, make it, or take out certain confidence level if you don't need so. And also created a consistent API for tracking annotators or zones and see how does it react on that. In addition to that, we also have classifications as well. If you want to have a classic format that just want to know what's in the picture and classify it, you can basically put your model in and then try to use the classification connector we have, and then it'll just give you the output in a standard format in the library we created too. And then we have annotators. Basically, annotators are visually shows you how the output of the object is looking on segmentation or detection. For example, we have many different annotators such as box, mask, or label annotators, and many other more, used to basically output of the model and shows you how it looks like. And also, it's also designed to assist the user interpreting what it looks like in the model and show you the results. So this is one example of the box annotator, but in order to see in a little bit more in real action how to plug it in, let's just switch into the other screen for a bit. In this case, we have the supervision already in the loaded. We have also the configuration which I use for as an image, and I'm going to use ultralytics model to plug my model in. And in this case, since I want to show you the masking, I'm going to use also segmentation model to show that you can see the result of it. And then after that, we have box annotator, label, and mask. Basically, they pretty standard. You give the detections. In the detections, you give another detections, and also in annotated images on one and on each other, basically shows you the result. So if I run it quickly, and wait a bit, there you go. It basically shows the basics of detection. As you guys can see, we have the class names, we have the sign, we have the names, we have the mask. For example, if I want to take out the mask in this case, let's just remove it for our testing purposes. And close this one out. Oh, sorry. Okay. Run again. And here you go. Basically, in the annotator visualization, you can take in or take out based on what you need. You can also manipulate it if you don't like it, so that's pretty much easy. For example, if I don't want the other signs, I just want to focus on persons, we can also do that in the detections result as well. So let's just come back. Then we have the track objects. Track objects are basically detection and model, not enough in single-handedly, because we need to also making sure that we need to have a consistent track of the model in the real time if you wanted to. In order to do that, we need some extra tools for that. For example, there are some algorithms out there. Some of them is getting, of course, improve in time, and some of them getting older because the development goes into the new algorithm in this case. So if I want to basically track people and see what is going on, we have in our library we have by track. For example, in the by track, basically we detect the model as usual we do in the previous example, and then we basically include a tracker. And with the tracker, we also say update detection with the tracker. It'll give them a tracker ID. With the tracker ID, basically the object become consistently trackable when they moving or get out of the scene, get into scene, when they get occluded or hidden in small amount of time. But that purely depends on the algorithm we are using into it, because in the end of the day, if the tracking object is gone for too long, it'll basically get a new ID. And in this div ID comes in, that means we are basically lost it in the previous ID. So there are a couple of ways to make sure this does not happen, but that also require maybe a stronger solutions or algorithm, even sometimes a custom solutions for that. In order to show this a little easier. Oh, sorry. So, okay, we have track object as well. Let's getting into it. Okay, if I run it quickly, basically it does do detections pretty quickly. We're just going to wait a couple of seconds. Okay. Okay. So as you guys can see, it's detecting persons, bags, whatever's in the model by default. They come into it, and once they are all detected, I'm just processing the video quickly to showcase what's in there, and it's almost should be done, hopefully. So this is the source video. And oops. And this is the detected video. Basically, as you guys can see, everyone has an ID, and sometimes they become gone and come back, but the ID try to stay same, because that's the way the tracker is actively working on it. Basically, trying to making sure that you don't lose the data when they're changing their position or changing their places. It's pretty useful if you have a real-time detections, and if you want to use that certain ability in the tracker. It's pretty standard. Everything we create in Supervision, basically we try to making sure everything is easily accessible and easily usable. So let's just remove this one, by the way, just old one. So first off, in the tracking, we have the model, and then we have the tracker. And after that, I just put my annotator down, showcase that this bounding box and the mask and everything. And after that, we have a detection happening here. And after that, I use my connector, then basically get the result of it. And also, I also include a filter that I only want the persons as a detection, and then rest of the detections be basically gone. When I was running into it, I got backpack, some other results. I don't want any of these. In my perspective, I only care about the persons. So that's pretty convenient in this case. And we update detection with the tracker and get the tracker ID. And then we just do some little loop On that, we try to get the tracker ID, the result names, and everything to showcase in the label on the video. I just showcased it. And after that, we basically annotate them, every single one of them, and then process the video, and the results basically came in. So that's basically the tracking objects. Pretty useful if you have a consistent things if you want to track on. That's basically comes in very handy. And the next one is we have the line zone. The line zone is basically, for example, you want to know how many people get in and get out in certain places, or you want to basically count the cars on certain areas like traffic systems or in IoTs in factories, and many use cases exist. So you don't need any kind of special sensor or some laser or stuff. In this case, we will going to use just purely a video input or a camera output to basically show the line zone. So we don't need so much of the things to do. Basically, what we do, we have to use the tracker because we need to make sure the object needs to be trackable. In this case, very important because tracker IDs are unique. It's like you have a username ID in your system that it's unique. So tracker ID is also unique. Once the ID is gone, it never comes back to it. So it's pretty useful that you always have a unique ID. So we set the by track, and we get the video frame. Then in here, we basically say this is my starting line, and this is my ending line. And then we have a line zone. So we draw the line, and after that, we keep processing it. And with the process, it basically shows you how many objects are get in or get out. So let's just show it in the demo immediately. Oops. Okay. You can click. There you go. So I'm counting the objects again to making sure, counting the cars and everything. Since this is a video, I'm pre-processing it. So while this is happening, let me show the code a little bit. It's pretty much standard. I have the starting and ending point. I have an example video. I'm using one more model to show that, okay, I want to track this. Of course, I'm using the byte tracker again to making sure I keep track of the vehicles. And then I have the bounding box, the label, and line zone annotators. I give some parameters. Some of them is visual, and some of them is showcase which one you want to see in or out. I want to see both of them. And then I have the line zone showcasing that I just want to making sure in my video, in my frame, I'm making sure I have the proper pixel coordinates. And after that, I create my detection again with the same connector, get the tracker ID, and doing some annotations magic. And after that, I'm basically also filtering certain classes. I just only want to have class ID number 2 and class number ID 7. I just want to print out which is in or which is out, and then that's it. So the video already has been processed, so let's just check the result immediately. And if I press enter, now as you guys can see, when the car is in or out, you can see which is in or which is out on both directions. Basically, the easy traffic counter system, just like that. No, just I don't know, over 50 lines of code, and that's it. Simple as that. Okay. Let's come back. So we have the key point. Before I go there, we have another zone. I forgot including into it. So let me also showcase that one as well. We also have the polygon zone. Similar to the line zone, it basically has polygons in the video that showcase that you have multiple areas that showing you which area has which objects in it. So let's just show this in a quick video first. Okay, there you go. So basically, as you guys can see, if I've stopped the video, you guys can see there's a multiple zones. There's an orange zone, red zone, and there's a purple zone, green and yellows and orange. It shows you basically which zone has how many people into it. And basically, we also have a counter in the middle of it. You can change the label whatever you want. In this case, we want to count which area they're into it. If I continue, you guys can see that it's changing the number certain times because they are consistently moving it. It's pretty useful if you want to know how crowd of the area for some heat map, or if you have a different objectives on certain cases, like, I don't know, for example, you want to check the aircraft business or some other traffic jams, and etc. It's pretty handy and useful in this type of cases. So, if I go back to the next one, so let's talk about the key points. The key points are basically can be pretty general in a sense that if you want to know which muscle is moving in this example, you can basically put a dot and knows which key points has been detected. The usefulness is if you have some sort of a, for example, a sports activity, if you want to know how many times you change your legs between them, or if you're doing some angle calculation based on your needs, or if you do some, I don't know, push-ups, you can easily calculate them based on your key points. Because the usefulness is you can basically use 3 key points in your muscles and basically find the angle between them, and it just gives you basically how many times you push-ups if you do a proper push-ups, for example. Or you can just use on some other I don't know, instead of a human, you can use on animals or other objects if you want to know certain volume of the objects, in case if you needed to, or if you want to have some sensitive detections that if you want to know which corner or which place is in or out based on the key points, basically. So in order to showcase it as well, this one, let me just swap into the code area. Okay, so I'm gonna smaller this one a little bit. Basically, everything is pretty much same until so far. Instead of detection, this time I'm using key points. I'm using the same connector, get the class names for later. And of course, we have annotators, connectors for that. For key points this time, edge, annotator, vertex. And then basically annotate them and showcase them what is going on. This time, I only have one picture, so it's going to be quick, basically. Where am I? Okay. Okay. Hopefully, yeah. Great. So basically, it just shows the number of the key point the model has been trained on. But this is a little bit ugly. Let's just fix this one a little bit more nicer. Just change the radius to 3, a bit more smaller. There you go. Okay, a little bit more smaller, but at least visually a little bit more better. So this model has been trained on humans, so it only shows the key points of the humans, basically. And it pretty much shows the number of the key points on the human, and with the annotators, we just basically visualize them easily. The green and blue, which are very distinguished. So greens are the vertex, and blues are the edges, which is the lines, and that's pretty much it. So, oh, I have the polygon zone. Okay, I basically swap between them. So I already mentioned of the polygon zone, so I'm skipping into it. So I have one more demo in the key point before I finish. But did I have the video of it already? Yes, good, great. So if I combine every single one of them, everything I just showcased so far, video first. So now I combine detection, key points, tracking and everything. So you can actually plug every single one of them to every single one of them. There is no limitation. You can basically visualize however you like and however you like into it. That's pretty much very easy to do in this sense. But if I want to show how is it possible, let me just close this one. Basically, we have the annotator as usual, same as that. We have some callback functions that doing this time detections, key point, and tracker, and rest of is basically detection, and that's it easy. So you don't have to rewrite a lot of codes and such. We basically try to generalize every single thing in computer vision because you can easily control the data however you like. And the beauty is, every data is pretty standard. Basically, we have multiple libraries, and we want to make sure that all of them is the same output. So when you use detections, every single one of them has XY in the output, and class IDs, confidence, or if they have a mask, and tracker IDs. We're making sure every single output from every single connector is the same. And we also have validations that making sure the number of the list in class ID, confidence, and coordinates is also the same. So we're really making sure that one basically works fine in this sense. And we have one more thing. So we have key points, but sometimes we want to make sure that in the last video I showed you that I would change the trackers to bounding box and making sure that it's also smooth and nicer. We have some other tooling that making sure if you don't want to have so many jittering, you can also prevent that a little bit. But of course, it comes with the price. If you do so much, it might slow down your detection. If you do less, it may jittering too much, depends on your cases. So just making sure that certain cases and applications needs to be adjusted based on your needs as well. So that's pretty much on me. If you have any questions on such, I'd like to see it. Okay, here you go. First one. Okay.
So thank you for the presentation. I have a question about tracking very speedy objects. Is there any limitations on speed of tracking very fast-moving objects?
In tracking?
Yeah.
If your camera can pick it up the frames fast enough that okay, so tracker doesn't limit it by the speed of the object. If your camera and your model can fast enough to pick it up the detections, we can track it. That's okay.
So, like, for example, when we're speaking about, like, I don't know, military drones, it is possible to track them with your software?
Yeah, of course. I mean, in a sense that, like, this is not just depends on the tracker. This also depends on how fast you detected the object. Because if you cannot detect fast enough, I can track it as well. Sorry, I cannot track as well, yes. Because we have a drone cases, you need to make sure your camera and your model run the hardware has to fast enough pick it up the object. It depends on FPS speed as well, in the tracking sense, in the real time. Because if I get all the frames fast enough and process it, I can include the tracker ID and track it easily, and I can say this is the tracker number ID, one drone, etc. Depends on the model as well.
So you say the hardware is a bottleneck in that case?
Hardware model, yeah, they are the bottleneck. Because trackering is algorithm in this sense. But if you use a tracker has a model included to it, like some detection tracking at the same time, then the idea is changed. Of course, this time your hardware is one case, the bottleneck, and your model also second bottleneck because maybe you train your model in a not in a good sense. It can prevent detecting the drone itself. That's a huge problem because then you can't even track it because you don't see it.
Okay, thank you so much.
Thank you. Any other questions? I guess there's not. Then thank you so much.